Hi everyone, today we're going to study Laplace transforms of division by t. Given the function f of t, if Laplace transform of the function f of t is equal to the function capital F of s, then Laplace transform of the function f of t all over t is equal to the definite integral from s to infinity of the function capital F of s ds. This is the working formula. Take note that the capital F of s is equal to Laplace transform of the function f of t. Example 1. Find Laplace transform of sin t over t. Our formula is Laplace transform of f of t over t is equal to this definite integral from s to infinity of the function capital F of s ds. In the given, the f of t here is the numerator, which is sin t. So for step 1, let us find the function capital F of s, which is equal to Laplace transform of the f of t, which means we're going to evaluate Laplace transform of this sin t. We know the formula, and the equivalent value is 1 over s squared plus 1. Then step 2. Let us evaluate the definite integral from s to infinity of the function capital F of s ds, which means from step 1, we will copy this value, we put it here. Then let us take the integral. We will have a formula for this 1 over s squared plus 1, and that is the tangent inverse of s. And from here, we will evaluate from s up to infinity. So we have these two groups. The first group is this function evaluated with respect to infinity, minus this function evaluated with respect to s. Please note that, by definition, the tangent inverse of infinity is equal to pi over 2. So we can substitute this value in here. So it becomes like this. Please remember also that we have an identity that says tangent inverse of s plus cotangent inverse of s is equal to pi over 2. When we manipulate this identity, we can use that to simplify this line here. So the final answer is cotangent inverse of s. Example 2. Find Laplace transform of cosine 2t minus cosine 3t all over t. We write our formula, and in the given, we collect the f of t, which is the numerator cosine 2t minus cosine 3t. Then we go to step 1. That is to find the function capital F of s, which is equal to the Laplace transform of f of t. Our f of t is here. Therefore, we will take the Laplace transform of cosine 2t minus cosine 3t, which is equal to s over s squared plus 4, that is for this cosine 2t, minus s over s squared plus 9, that is the Laplace transform of this cosine 3t. Then we go to step 2. We evaluate the definite integral. From step 1, we substitute the value of capital F of s, so it is in here now. Then we will do substitution to get the integral of each of the fraction. I'm going to put the link of the video for integration by substitution. The integral of s over s squared plus 4 will be 1/2 times natural log of the absolute value of s squared plus 4 minus the integral of this s over s squared plus 9 is now 1/2 times the natural log of the absolute value of s squared plus 9. From here, we can factor out the common fraction, which is 1/2. So this line becomes like this. And to simplify further, we will apply the law of logarithm, so it becomes like this. 1/2 times the natural log of the fraction s squared plus 4 all over s squared plus 9. Then let us evaluate this with respect to s and infinity. Considering the infinity, let us rewrite our fraction into this form. So in the numerator, we have s squared times the quantity 1 plus 4 all over s squared all over. For the denominator, we have s squared times the quantity 1 plus 9 over s squared. Then we can cancel the s squared in the numerator and the s squared in the denominator. Then we can simplify further the fraction into like this. From here, let us now evaluate this fraction with respect to the limits. So we have here the two groups. The first group, we evaluate this function with respect to infinity, minus the second group. And this is the evaluation of this function with respect to s. In the first group here, this 4 over infinity squared will be equal to 0. Also, the 9 over infinity squared is also equal to 0, which means 1 plus 0 is 1 over 1 plus 0 is also 1. Therefore, 1 over 1 is simply 1. So in the first group, we have now here ln of 1 minus the second group, which we copy down here. We know the value of ln of 1 is equal to 0, which means that 0 multiplied by 1/2 is simply 0. So the next step is we have only the second group in the next line, and it is like this. From here, let us simplify the complex fraction. We write like this. The numerator becomes s squared plus 4 all over s squared, and the denominator becomes s squared plus 9 all over s squared. From here, we can cancel those s squared respectively. When we rewrite our fractions, we have now s squared plus 4 over s squared plus 9. Let us use the law of logarithm to rewrite the expression, and it becomes like this. Then this negative 1/2 outside, we will multiply to each of the terms of the grouping symbol. So we have like this. We can simplify again this line using the laws of logarithm, and it becomes like this. 1/2 times the natural log of s squared plus 9 all over s squared plus 4. This is the final answer. Example 3. Find the Laplace transform of 1 minus e raised to negative t all over t. We write our formula, and in the given, we say that the f of t is the numerator, and that is 1 minus e raised to negative t. Then we go to step 1, that is to find the function f of s, which is equal to the Laplace transform of f of t. Our f of t is here, which means we need to simplify Laplace transform of 1 minus e raised to negative t. We will take Laplace transform respectively. For the number 1, we have the 1 over s minus, for this e raised to negative t, we have 1 over s plus 1. Then step 2, let us evaluate the definite integral. We substitute the value from step 1, so it becomes like this. Then we will find the integral using substitution method. the 1 over s becomes natural log of the absolute value of s, minus this 1 over s plus 1 is now natural log of the absolute value of s plus 1. Then we use the logarithm law to simplify. So we have now ln of the fraction s over s plus 1. From here, we will evaluate with respect to s up to infinity. In this fraction, let us rewrite the denominator. So it becomes s times the quantity 1 plus 1 over s. We can see here that we can cancel the s in the numerator and the s in the denominator, which means the new expression is now ln of 1 all over the quantity 1 plus 1 over s. Next step, let us now evaluate this function with respect to s and infinity. So we have here the two groups. The first group, this is with respect to infinity, minus the second group with respect to s. In the first group, we have this 1 over infinity, and this is equal to 0. So we have here 1 over 1, which is ln of 1, minus, in the second group, we will simplify this 1 plus 1 over s. Combining this, we have now this s plus 1 all over s. Look at the first group. ln of 1 is equal to 0. Also, in the second group, we're going to simplify the complex fraction. So the second group now becomes like this, the negative of the ln of s over s plus 1. Let us now rewrite this expression with respect to the law of logarithm. So we have now this negative of the quantity ln of s minus ln of the quantity s plus 1. Then we multiply the negative sign from outside going to the terms inside. So we have now this negative of ln s plus the ln of the quantity s plus 1. And let us rewrite this again with respect to the law of logarithm. So the final answer will be ln of the fraction s plus 1 all over s. I hope you learned something from this video. See you again next time.